Students, are you able to hear me?
Yes, sir.
Okay. So we'll get started. So the last topic that is left out in waves is the Doppler effect, right? So we will see that part and then we'll move on to electrostatics. We'll do some one or two problems based on Doppler effect, then we'll move on to the next chapter. So I'm sure everybody will have heard the word Doppler effect, right? Can someone tell me what does it mean? So what does this Doppler effect actually mean? Anybody? So what does Doppler effect mean, and specifically with respect to sound? So it's very simple. If there are two objects which are having a relative motion between them, okay? So if there are two objects, what are the two objects? One is called as the observer and the source. So if the observer and the source have a relative motion with respect to them, where if you consider four velocities, v, v naught, vs, and vm, where these are the velocities of the sound. V stands for the speed of the sound, that is generally around 340 meters per second in air medium. Similarly, V naught stands for the velocity of the observer, Vs for the source, and Vm for the medium respectively. Then what will happen is, if there is a relative motion existing between them, then rather you will not be able to hear the original frequency, but you will hear something called as the apparent frequency. And the apparent frequency is given by the equation f dash is equal to velocity of the sound plus velocity of the medium minus velocity of the observer divided by, please make a note of this formula, velocity of the sound plus velocity of the medium minus velocity of the source multiplied with the original frequency of the sound. This is the frequency of sound. This is the real frequency, not the apparent. Apparent means the change value. Okay. Suppose sometimes what happens is, if the medium is at rest, if Vm is equal to 0, then f dash is given by the expression V minus V naught divided by V minus Vs multiplied with f. Okay. V minus V naught divided by V minus Vs multiplied with f. Here, there is a sign convention that we need to follow. So, with respect to the, see, all the velocities are considered as positive in the source to observer direction and negative in the opposite direction, that is observer to source. Okay. So, whenever there is an object which is, so any direction, if suppose this is the source, this is the observer. So generally that is how we take. Source is taken on the left hand side, observer is taken on the right hand side. Any velocity that is in the direction of source to observer is considered positive. Any velocity in the direction of observer to source is considered as negative. Okay. So I'm not going to show you the derivation at all. That is not needed. We are only going to see how to apply it. Okay. So please make a note of this. I hope you're done. Now listen. Okay. Now listen. Suppose a question is like this. A source and an observer, are approaching one another with the relative velocity of 40 meters per second. If the true source frequency is 1200 hertz, deduce the observed frequency under the following condition. All velocity is in the source alone. Second is all velocity is in the observer alone. Third is the source moves in the air at 100 meters per second towards the observer, but observer also moves with the velocity v0 in the same direction. Okay. So read the question carefully. Tell me how do we proceed. Okay. I hope everybody has read the question. No. Listen. So what is the original frequency of the sound? It is 1200 hertz. So what have they given? They have given the relative velocity, that is velocity of the source plus velocity of observer is 40 meter per second. Can someone tell me why did I write plus?
They're approaching each other.
Yes, they are approaching each other. Means the source is in this direction, observer is in this direction. Okay. Now, we need to reduce the observed frequency, that is the apparent frequency by the observer. In the initial case, all the velocity is by the source alone. Means, case 1, what are they saying? Vs plus V0 is equal to 40. But in the first case, if all the velocity is associated to source alone, what will be the value of V0?
0.
0. So, V minus V0 divided by V minus Vs into F. Right? So, V minus 0 divided by V minus the source. See, velocity of the source is taken as positive because anything in the rightward direction is positive. V minus, what is the value of Vs? It is 40 multiplied with 120. Okay. So, V is how much? They didn't give it actually. But generally, the speed of the sound is 340. So, 340 divided by 300 into 120. 5 times, 2 times.
Sir, it's not 1200. Huh?
1200. Sorry. So, it will be 20, right? So, 5 means it is 68. So, 68 into 20 is 1360. If you observe, the frequency has actually increased. Okay. So, whenever the source is approaching the observer, right? That is a stationary observer, the frequency tends to increase. So how to realize this is, if suppose you have a car, okay, suppose the car is producing, they're honking, okay, they're blowing the horn, and with the continuous blowing of the horn, if they approach towards you, you're the observer, will the frequency of the horn keep increasing or decreasing? Will you hear it more shrill? So you'll feel the frequency is more, right? The same thing is happening. Though the original frequency generated by the car is only 1200, but since it is approaching towards the observer, its frequency is appearing as more. It is because of whom? Because of the relative velocity. Now you people do what will happen if all the velocity is by the observer alone. Do it fast. So what will happen? In the case of Vs plus V0, Vs will be 0. V0 will be how much?
40 meters per second.
It will be minus 40 because V0 is approaching towards the source. Velocity in this direction is negative, no? Got it?
So it's 1058 hertz.
So let's do it. So what is it? F dash is equal to, just a minute guys, I'll turn. So f dash is equal to, tell me, v minus v naught divided by v minus vs into f. So v minus v naught means 340 minus of minus 40, the whole divided by 340 minus 0 into 1200. So 380 divided by 340 into 1200. This and this will get cancelled. This will go 19 times, 17 times, whatever is the answer, that those many hertz is the final answer. Is that what they are getting? Yes, 1341. Here also, if you see, actually it is increasing. For example, the car is continuously blowing the horn, but if you move towards the car also, you will see that the frequency has increased. Correct? Now the third part is a tricky one. The source moves in the air at 100 meters per second. So velocity of source is how much? 100 meter per second. I hope that part is clear. But the observer also moves with a velocity v naught in the same direction. Then what is the value of v naught? Remember, Vs plus V naught is equal to 40.
Minus 60 meter per second.
How much?
Minus 60.
It would have been minus 60 had it moved in the opposite direction. But they're saying it is moving in the same direction, and the point, Goni. It is moving in the same direction. Okay. So this approaching towards each other is applicable only for the first and the second. So what should the answer here be? It should have been plus 60. That is when Vs minus V naught will be how much? 40 meter per second. Correct?
Yes, sir.
Right? So f dash will be V minus V naught divided by V minus Vs into f. So 340 minus 60 divided by 340 minus 100 into 1200. So how much is that? 280 divided by 240 into 1200. 0, 0 gone. 100 times 2 times 14. It will be 1400. So it will be 1400 hertz. Okay. So here the trick is only about taking the right sign convention. I hope you're clear, guys. Okay. Now try this question. We'll do one last problem, then we'll go to electrostatics. A railway engine and a car are moving on parallel tracks in opposite directions with a speed of 144 km per hour and 72 km per hour respectively. Okay. The engine is continuously sounding a whistle of frequency 500 hertz. The velocity of the sound is 340 meters per second. Calculate the frequency of the sound heard in the car when the car and the engine are approaching each other. The two are moving away from each other. Try this. Tell me. So velocity of railway engine is 144 km per hour. How many meters per second is this? Into 5 by 18. How much is it giving?
40.
40 meter per second. So velocity of the car is how much? 72 kilometer per hour. It is 20, right? It is 20 meter per second. Now, velocity of sound is 340 meter per second. And the original frequency of whom? Of the whistle is equal to 500 hertz. Velocity, calculate the frequency of the sound heard in the car when the car and the engine are approaching each other. So only one formula, F dash is equal to V minus V naught divided by V minus Vs multiplied with F. So V minus V naught means 340 minus, who is the observer here? Sound heard in the car. So car is the observer. So what is the velocity of observer? It is 20, but they are moving towards each other. So what will be the velocity of the observer? It will be minus 20 divided by, yes, 340 minus velocity of the source is plus 40. So 40 multiplied with 500. So how much is answer? 340 minus of minus 20 is 360 divided by 300 into 500. Cancel 3, it will go 12, 120 times 120 into 5 is 600 hertz. So whenever they are approaching each other, the frequency will increase. 600 hertz is the answer. Right. Now let's think of the other case. The two are moving away from each other means F dash will be 340 minus 20 divided by 340 minus 40 into 500. Because everything will be positive. 340 minus 20 means 320 divided by 300 into 500. Gone 2 times. So 32. So answer will be approximately how much? 11 means 11 into 5. Did I do any mistake?
33.3, sir.
Oh, when the two are moving away from each other. So source, the two are moving away. Source and observer. Source is moving in the leftward direction. Observer will move in the rightward direction. Actually, it should decrease. So let's say they have crossed each other. Now the source is, see, always source is taken on the left, okay? Source is taken on the left, observer is taken on the right. As far as possible, don't take the source velocity to be negative. Means if that should happen, what we can do is, source and the observer are moving towards each other. Once they cross each other, observer will keep moving to the left and the source will keep moving to the right. So F dash will be how much? V minus V naught divided by V minus Vs into F. So V is 340 minus, now tell me, velocity of the observer even then if I do it like this, okay, let's do one thing. Let's stick to the same logic. Source is like this, observer is like this. Okay, you take it like this. Okay, this is the way they are moving away from each other. Now, velocity of the observer will be positive. How much is the velocity of observer? 40 or 20 divided by 340 minus, what will be the velocity of source? It will be minus 40. Correct? Into 500. If there is any doubt, get it clarified. So 320 divided by 380 into 500. Cancel, cancel. So how much is the answer? It should be definitely less than 500. See, I got a doubt because here my answer came out to be greater than 500. It came out to be approximately 550. That is not possible. See, logically, when two objects are moving away from each other, what will happen to the frequency that we'll hear? It will tend to decrease. It cannot increase. So this one is right because 32 by 38 is less than 1 into 500. It will be something less than 500. So how much ever is the answer that you
421.
can calculate? 421. So 421 hertz is the answer. But I hope you understood the logic. So all the problems have to be solved using this approach only. This is the only formula you have for Doppler effect and the only method to solve. Okay. I hope things are clear. Right.
Yes, sir.
Now we will get started with your 12th standard. So that is, we are going to solve problems based on electrostatics. Okay. So going forward, I'm going to concentrate more on problems only, not much of theory. I assume that your theory is good enough. But if there is any concept that you want me to explain, I will definitely explain. But you have to let me know, or else I will be under the assumption that you know the concept. Okay. So we know that electrostatics, we know the basics of charges and all those things, right? Charge is quantized, you have additive nature of charge and the conservation of charge. All those are simple aspects. Next is, to solve the problems, the basic that you need to start with is Coulomb's law. So Coulomb's law is applicable for point charges which are at rest. So when the point charges are at rest, F is equal to K Q1 Q2 divided by R square, where Q1 and Q2 are the magnitude of either of the charges and R is the distance of separation between them. Right? So this is the formula that we need to know. Similarly, whenever you have extended charges, okay, you have extended charges and you need to apply Coulomb's law, because Coulomb's law is applicable for what? So
Point
when do you apply
charges.
Coulomb's? It is applicable only for point charges. When you have extended charges, how you are supposed to apply is, see, suppose there is a rod and there is a point charge. This rod is of finite length. Let's say this is of length L. Now, no more I can call this as a point charge. And let me say the total charge that is there on this rod is plus capital Q. Then what you need to do is, listen to this carefully. Not only here, wherever the theory is going beyond the statement. For example, here Coulomb's law is applicable only for point charges. Extended charge, it doesn't speak, right? Whenever the concept of extended comes, the method you need to follow is calculus. So for that, what you need to do is, you need to consider a small charge, okay, dq, and from dq, your work is to measure the distance between them here, and then you need to look into the number of variables that you're going to introduce. Okay, how many variables do we have now? You have dq and you have r. So there are two variables. So when you need to apply Coulomb's law, so when you have these two charges, no, you cannot define the exact force. Rather, you can define only the infinitesimally small force. dF will be equal to k into dq into q, the whole divided by r square. Guys, are you able to understand? So here I could find only dF. I couldn't find f. So for me to find f, what are we supposed to do?
Integrate.
You need to integrate it. But remember, integration can be done only when you have one variable, at least according to your syllabus, right? So you need only one variable. So you need to integrate it with respect to the variable dq. But here r is also a variable. So what we need to do is, we need to start introducing, if possible, in these kind of problems, you need to start introducing trigonometry. If you recollect the Biot-Savart law concept, where I try to derive it for a finite rod, a current carrying conductor of finite length, you would have followed trigonometry, right? If I take this distance as x, then this x is always a constant because it is always a perpendicular distance. So what logic I'm trying to say is whenever you're approaching, you need to look at the constants and the variables. So when you need to integrate, there should only be one variable. So what we can do here is r divided by x. What can I call it as? So r
Secant
divided by
theta.
x. So secant theta. Then what you need to do is r, you need to write it in terms of secant theta. So k dq into q divided by x secant theta the whole square. Then we need to think of the limits. So I've just given you an outline of what we are supposed to do. Okay, I'm not concerned about what is going to happen here because the question is incomplete. But are you able to understand what you're supposed to do whenever there is a function that comes into picture? Especially with respect to Coulomb's law, because all the problems that we are going to solve today will be something similar like this. At that point, you should not struggle. So are you guys able to understand how to implement calculus, how to apply integration into your physics? So integration cannot be a individual topic. It has to be a combination of both. Right? Integration and differentiation should come into picture. So if you're clear with this concept, let me explain everything in terms of problems. Shall I proceed?
So 1 minute, I'll just copy that.
Yeah. Done?
Yes, sir.
Okay. Now listen. So the first concept, first topic that we are going to deal with, electrostatic force and field strength. Similarly, we have seen what is an electrostatic force. That is nothing but based on Coulomb's law. If I ask you what is the field strength, what will you say? Students, are you able to hear me? I had a power cut.
Yes.
Now listen. So when I talk about the field strength, what comes to your mind? It is the electric field strength that we are trying to talk about. So how do you measure the electric field? First, you calculate the force. So let's not look into the formula of kq by r square. How did it actually come? If you are able to calculate the force between a source charge and a test charge and divide it with the magnitude of the test charge, then that parameter is what is called as the electric field strength. Am I right? So here, if suppose you have a variable force, then you need to follow the above procedure and divide it with Q naught. That's going to give you the answer. So these are the two logics which we are going to apply in the problems. Let's see. So let's start with this. Let a total charge 2Q be distributed in a sphere of radius capital R with a charge density given by the expression rho of R is equal to K into R. Okay, accepted. Where R is the distance from the center, two charges A and B of minus Q each are placed diametrically or placed on diametrically opposite points at equal distance A from the center. if A and B do not experience any force, then what is the value of small a? Okay, how do we solve this? Anybody with the idea? I'll just tell you one thing, it's not a simple problem for sure. But I just want the idea alone. Did you guys understand the question? Okay, we'll do one thing. I'll do little simple, a bit simple problems, and then we'll come to this. Okay. Next. So we'll start with fifth one. 3 charges plus Q, Q, and plus Q are placed respectively at a distance of 0, d by 2, and d from the origin on the x-axis. If the net force experienced by plus Q at x is equal to 0 is 0, find the value of Q. So at least this, can you guys tell me? So what is the question? There are 3 charges. What are they? Plus Q, Q, and another plus Q, which are placed at origin d by 2 comma 0 and d comma 0, right? Am I right? Now the question is, F net by first charge is 0. So what is the net force experienced by this charge due to the other 2 charges? If I call this as ABC, so what is the force that is existing between A and B?
K capital Q, Q divided by D by 4 the whole square. D by 2 the whole
So d
square.
square, d by 2 the whole square. What is the force between A and C?
K
1
Q
by 4
square
by
by D square.
capital Q square divided by A square. So the net force experience is it not equal to the force between AB plus force between AC? That is KQ divided by D square into 4Q plus Q. Right? So this net force is 0, which implies 4 times small q is equal to minus q, which implies q should be minus q by 4. Right? Next. Okay, leave the advanced one. Let's not do it. 7th one. 2 point charges, each of magnitude q, are kept at x is equal to minus a and x is equal to plus a on the x-axis. A particle of mass small m and charge q naught is equal to q by 2 is placed at the origin. If the charge q naught is given a small displacement y, very much less than a along the y-axis, the net force acting on the particle is proportional to what? So what is the answer, guys? How to do?
So minus 1 by y.
Y minus 1 by y.
Sir,
So how do you want me to?
Sir, it's
Yeah, tell me.
I didn't use formulas and all, sir. I just use logic. So if it's dislodged from its, if it goes up a little, there will be a slight reduction in force, no, sir.
Okay.
So if y increases, then f decreases.
Okay, but that's not the logic here. I am able to understand what you're thinking. See, wherever the small displacement concept comes, no, where did we see the small displacement? Which chapter we were concentrating more on the small displacement? Is it not SHM? So, what are the two charges that are present? There are two charges Q, which are placed at minus a comma 0 and a comma 0. And there is a particle Q naught, which is exactly half of this value, is slightly displaced from its equilibrium position and left. So what will happen is, then there will be a force that is existing at Q naught in this direction. Okay, Q naught, is it negative? On the y-axis.
Sir, sorry, what did you ask, sir?
My starts Q naught is negative. Q naught has to be negative for this kind of a thing to happen. I think there is a mistake in the question. What would have happened is, if Q naught is positive, okay, I'll explain the logic. I think there is a mistake. Had Q naught been positive, what would have happened is, this particle, so due to plus Q, it will experience a repulsive force along the line joining. Due to this plus Q, it will experience a repulsive force in this direction. So the resultant will be in this direction, as a result of which, this particle, even if it is slightly displaced, there is no tendency for this particle to return back to its equilibrium position. And none of my expressions are looking like that. Right? See, for example, if I have to declare it as y or minus y, it should be in SHM. If I have to declare it as inversely proportional to y, then I have to prove it is in circular motion. None of the things can happen, right? So question is actually wrong. Here it should have been minus Q naught. Had it been minus Q naught, then this will come in this direction. The particle will start moving in downward direction. As a result of which, see, are you guys able to understand the logic I'm trying to say? So there is a mistake in this question. If there is a mistake in the exam, you will get marks. Don't worry about it. So this is Q. This is another Q. This is Q naught, which is minus Q by 2, okay? It will travel in this direction like this. Now, if I call this force as F, this force also as F, then if I take this angle as theta, this angle also as theta, then F can be resolved into two components, F cos theta and F sin theta. Similarly, F cos theta, F sin theta. What will get cancelled? F sin theta is gone. Okay. So 2F cos theta is providing the necessary restoring force. So how much is the value of 2f cos theta? So 2 into, what is the value of f? It is kq divided by, if this is y, this is a, root of y square plus a square, which is approximated to how much? So it is root of y square plus a square, the whole square, that is kq by r square, into what is the value of cos theta, guys? A divided by root of y square plus a square. If there is any doubt, let me know. So
Sir,
2kq.
so minus q by 2, sir.
Yeah, I missed it, right? Yeah, it is minus q by 2. So if I take only the magnitude, it will be plus q by 2. Generally, when you write the force, you take only the magnitude, right? Because the direction is taken care by the vectors. I would have told this many times. So 2 and 2 will get cancelled. Kq square a divided by y square plus a square, the whole power 3 by 2 is what is the value? Oh, sorry. It is y divided by root of a square plus. Since y is very much less than a, y square plus a square can approximate it to a square. So then what will happen is kq square divided by a cube into y. This is the net force. Now tell me the net force is proportional to whom?
Y.
That's the answer. But did you guys understand the logic?
Yes, sir.
Clear? Now I'll move on to the next question. Can we do slightly tougher problems? Students, they are not easy, but I want you to concentrate. So charge is distributed within a sphere of radius capital R with a volume charge density rho r is equal to a by r square into e power minus 2r by a, where a and a are constants. Q is the total charge distribution. The radius capital R is equal to how much? Okay. So did you guys understand the question? So there is a sphere. There is a sphere. And with respect to the sphere, where is the charge distributed? Read it carefully. Charge is distributed within a sphere of radius r with the volume charge density this much. Means the sphere is solid and inside there is charge. But the question is the charge distributed uniformly? Think about it. Is the charge distributed uniformly?
No, so it's a function of R.
No, sir.
It is a function of r. Right? So rho of r is equal to capital A divided by r square into e power minus 2r divided by a. So wherever the concept of function comes, you have to solve the problem only using integration. So they are asking you what is the total charge. It is not practically possible. See, had it been q divided by 4 by 3 pi r cube, then you would have multiplied exactly with 4 by 3 pi r cube, you would have got the total charge. But here you can't get it. So for that, what you need to do is you can only, so whatever is the parameter they are asking, you have to first find the infinitesimally small value of it. For that, what you need to do is you need to consider a shape. So with respect to a sphere, what is the shape that I can think of? Can I think of a sphere like this? Right. So if I take the sphere like this, let me say this distance is r, and generally you need to call the thickness of that sphere as dr. Okay. And what is the radius given? The radius of the sphere is capital R. Is there any doubt in this diagram? Now my question is, what is the value of dq? That is, what is the value of charge that is present within the small surface that I have found? That is rho of R into, can I call it as dV? Because rho is equal to dq by dV also. Correct? So Q will be equal to integral of rho dV. So this is going to be the formula for this question. Is there any doubt, guys?
No, sir.
Okay. So what is going to be the volume of the sphere if I ignore the thickness? Volume is 4 by 3 pi small r cube. If dr is ignored, then what is the value of dV? Is it not 4 pi r square dr? Okay, this is one way of obtaining. This is the better way. Right, dV is, you understood how I got that dV is equal to 4 pi r square dr? It is because I differentiated. Take this and substitute it here. So what is the value of rho? A, capital A by r square into e power minus 2r divided by A into 4 pi r square dr. And here, what is the variable?
R, sir.
What is the variable? Yeah, it is smaller because you're integrating with respect to r. So small r is varying from where to where? From the center, it is 0 till the tip, it is r. So can I write it as 0 to capital R? Now be careful. This r square are gone. 4 pi a has come out. Integral of 0 to r. E power minus 2r divided by a into dr. Right. So 4 pi a into, what is the integral of e power minus x? It is e power minus 2r divided by a, the whole divided by minus 2 by a. From where to where? From 0 to capital R. So 2 will get cancelled. Minus 2 pi capital A into small a into e power minus 2r divided by a minus 1. Guys, I hope you understood. Please make a note of this point. So e power minus 2a, 2r by a. So this is the value of q, but what are they asking? If the q is the total charge of this distribution, then the value of capital R is how much? So for that, observe guys, it's not at over. 2 pi small a into capital A into 1 minus e power minus 2r by a. Accepted. So what I'm going to do is q divided by 2 pi a into capital A is equal to 1 minus e power minus 2r divided by a. Okay. I'll bring this e this side, this q by 2r, 2 pi into something to the other side. So e power minus 2r divided by a is 1 minus q divided by 2 pi into small a into capital A. So if I want capital R from here, what am I supposed to do? Take log base e on both sides. If you take that minus 2r divided by a is equal to log of 1 minus q divided by 2 pi small a into capital A. So what will be the value of capital R, guys? A divided by 2 into log of 1 minus q divided by 2 pi small a into capital A, and there is a minus sign. Okay, wait, actually what I should have done is, since R has to be capital, so tell me this thing, guys, are you clear with this step? The one which I put a tick. Are you clear with this step?
Yes, sir.
Yes, sir.
Now, if I take e power 2r divided by a, then what will it be? It will be 1 divided by 1 minus q divided by 2 pi into small a into capital A. So log of, it would have been 1 by, this is the answer. That is, I took the reciprocal and then I did. So it will be R is equal to a by 2 into log of 1 by 1 minus q divided by 2 pi into small a into capital A. Clear? So if there is any doubt, get it clarified. No. Can you guys try this problem? 2 point charges Q1, which is root 10 microcoulomb, and Q2, which is minus 25 microcoulomb, are placed on the x-axis at x is equal to 1 meter and x is equal to 4 meter respectively. The electric field in volt per meter at a point y is equal to 3 meter on the y-axis is given by. How do you solve? You try to solve. So 2 point charges Q1 and Q2 are placed on the x-axis at x is equal to 1 meter and 4 meter respectively. The electric field at a point y is equal to 3 meter on the y-axis. It's simple trigonometry, we'll get the answer. So what is the electric field due to a point charge at a distance? What is the electric field due to a point charge at a given distance? So what is the doubt in this? Are you guys there?
Yes, sir.
So what is the answer for that? Electric field due to a point charge at a distance r from it. K
A
cube.
cube by R square.
That's it. So you have to apply that formula, you will get the answer. So if I take this as the origin, there are 2 point charges, Q1 and Q2. 1, 2, 3. At a distance of y is equal to 3 meter on the y-axis, you need to find the electric field. It's simple. So Q1 is root 10 microcoulomb. Q2 is how much? Minus 25 microcoulomb. Right. So due to Q1, there will be a charge electric field in this direction. Let me call it as E1. Due to Q2, there will be an electric field in this direction. Let's call it as E2. If I call this as theta 1 and theta 2, because I am able to see a right angle triangle, so I thought trigonometry will help me. So what is the electric field due to the first charge? If this is 3 and this is 1, how much is this distance? Root of 10.
Oh,
So K Q by R square. This is theta 1. Let me draw a line. So this will also be theta 1. So E1 cos theta 1, E1 sin theta 1. Okay. So if I have to write this electric field as a vector, then K into root 10 divided by 10 into cos theta 1 of minus I cap plus sin theta 1 in which direction? The direction of J cap. So what is cos theta 1, guys? Is it not 1 by root 10? 1 by root 10 minus I cap plus 3 by root 10 J cap. So root 10 is gone. 9 into 10 power 8 into minus I cap plus 3 J cap is the electric field 1. Similarly, can you guys calculate the second one and tell me? What is E2, guys? So E2 is in this direction. This is theta 2. Then this will also be theta 2. So E2 cos theta 2 cos theta 2 is 4 by 5 I cap. Sin theta 2 is 3 by 5 minus J cap. That is 9 into 10 power 9 into, what is the value of Q2, guys? Minus 25. Yeah? So you add both, that is going to give you the answer. Did you guys understand? So this is also a good problem because it is an application of electrostatics and vectors also. Are you able to understand? So in your 12th standard, all the problems will be something similar. It will be a combination of one or two concepts. Any doubt?
Sir, how do you add both?
Just add the vector area.
Oh, root of...
No need, even vector plus e to vector. You
oh,
don't take the
directly add the
square.
coefficient.
Yeah, because the answer is given in terms of I cap and j cap.
Oh, okay.
Yeah.
I thought you should find resultant.
No need.
Okay, sir.
See, if you have to find resultant, we could have found it there itself.
Yes, sir. That's what I was thinking. I didn't see the options.
No problem. So let's do the second one. So 4 point charges minus q plus q plus q and minus q are placed on the y-axis. At y is equal to minus 2d, y is equal to minus d, y is equal to plus d, y is equal to plus 2d respectively. The magnitude of the electric field E at a point on the x-axis at a distance x is equal to d, where d is very much greater than d, will behave as. Try this, no? So 4 point charges minus q plus q plus q and minus q are placed on y-axis respectively. At y is equal to, instead of taking vertically, I'll take it horizontally. Let me call this as y-axis. Minus q plus q plus q and minus q are placed at minus 2d, minus d, d and 2d, where this is the origin. The magnitude of the electric field E at a point on the x-axis at a distance x is equal to d. So you need to find the electric field at a point on the x-axis, which is at a distance d, where capital D is very much greater than small d. Okay, this will behave like what? So do you guys remember the way we derive the electric field due to a dipole? So wherever you have root of d square plus capital D square, what should it be approximately when this condition is given?
D.
Capital D.
Yes, you write it as capital D. Right? Same logic is applicable here also. Try them out. I think we'll better go with the original thing because we need to involve cos theta, because is it not looking like similar to a dipole, except the fact that there are 4 charges. So you have plus q minus q plus q minus q. This is the distance capital D. Right. So due to the negative charges, what is the direction of electric field? It is in this direction. Let me call it as E1. Due to this negative charge also, the magnitude will be the same because they are symmetrically distributed even. Due to the positive charge, the electric field will be away from it, which is E2. And due to this positive charge, it will be away from it, which is also E2. Okay. Now, for me to find the net electric field at this point, I need to resolve them into components. So whenever I speak about resolving, I need to introduce angles. So if I take this as theta1 because it is E1 that is involved, then this will be theta2 and this will also be theta. Guys, are you able to understand? Right.
Yes, sir.
Theta 2. This will also be theta 2. And this will also be theta 2. So what is the net electric field at point P? It is 2 times E2 cos theta 2 minus 2 times E1 cos theta 1. Okay. This is the net electric field because the vertical direction things will get cancelled. So 2 times, what is the value of E2, guys? It is K times Q divided by, how much is this distance? This is 2D and this is D and this is capital D. So this distance will be root of D square plus 4D square. So 2 times and E2 will be how much? Root of D square plus small d square. So KQ divided by square root of D square plus D square into what is the value of cos theta 2? Cos theta 2 will be D divided by root of D square plus D square minus 2 times what is the value of E1, guys? Q divided by root of D square plus 4D square into cos theta 1. Cos theta 1 is D divided by root of D square plus 4D square. Okay. There is too much of math involved. So 2 times KQ into D divided by D square plus D square the whole power 3 by 2 minus capital D involved by D square plus 4D square the whole power 3 by 2. Okay. Now to do the approximation, what can we do? See, this D square plus D square can be approximated to D square. That's not an issue. Right? That's not an issue. But what will you do for D square plus 4D square? Because you cannot say that is approximately 0. So what we need to do is, we need to take out the bigger variable. So if I have to take out the bigger variable out of D and small d and capital D will come out 2q kq divided by, if I take out D square outside, what is it going to come out as? D cube into, can I write it as 1 divided by 1 plus D square divided by capital D square the whole power 3 by 2 minus capital D is also there. D divided by, it will be 1 plus 4D square by capital D square the whole power 3 by 2. Guys, tell me, is there any doubt in this? No. 2kq divided by D square into 1 plus D square by capital D square the whole power minus 3 by 2 minus 1 plus 4D square by capital D square the whole power minus 3 by 2. Tell me one thing. 1 plus x the whole power n is approximated to how much when the value of mod x is very much less than 1?
1 plus nx.
Apply the same logic here. D by capital D. So D square by capital D square is very much less than 1. Right. So when you apply the logic, 2kq divided by D square into 1 minus 3D square by 2 capital D square minus 1 minus 2D square, not 2, 6D square divided by capital D square. Can I write it like this? Or I will write it as 12D square by 2D square. Right. So 1 will get cancelled. What is that you're left out with? 12 minus 3, 9. So 2 times kq divided by d square into 9 times d square divided by 2 capital D square. Correct? So 18 times kq d square the whole divided by d power 4 is the value of net. Now what are they asking? This is the value of the net electric field. It will behave as the electric field is inversely proportional to whom? You guys tell me.
D power 4.
That's the answer. Sometimes there will be a lot of math involved also. Done? So it's at 4:47. Okay. So first problem is also tough that I will do later. Okay. We can do one last problem and wind up the session. You guys think and tell me. 6 charges, 3 positive and 3 negative of equal magnitudes are to be placed at the vertices of a regular hexagon such that the electric field at O is double the electric field when only one positive charge of the same magnitude is placed at R. Which of the following arrangements of charge is possible for PQ, RS, TU respectively? No other option. You have to try out using trial and error only. So what is the answer? So you guys try this as homework.
Sir, is it C?
C. How are you saying? So you want to keep it as positive, positive, negative, positive, negative, negative. Okay. Due to this, what do you think will happen? Due to P, if the electric field is in this direction, due to S, the electric field will be in the opposite direction. So it will get nullified. P, that is P and S will get nullified. U and R will also get nullified. What about Q and T?
I think I did a mistake.
Check it. Okay. So this part you can take it as homework. See, a charge Q is placed at the center of the line joining two charges, capital Q. 1987, the 2-mark question got repeated in 2019. So sometimes that will happen. That's why it's important to practice the previous year problems. Okay. So let's do the 9th problem, then we can wind up. An electron of mass ME initially at rest moves through a certain distance in a uniform electric field in time t1. A proton of mass MP, also initially at rest, takes time t2 to move through an initial distance in this uniform electric field. Neglecting the effect of gravity, the ratio t2 by t1 is nearly equal to. So important point that is given is they travel through the same distance. So S is equal to UT plus half AT square. So S is the same. U is 0. So half A1 T1 square is equal to half A2 T2 square. So they're asking T2 by T1. So T2 by T1 is equal to root of A1 by A2. So if I take T2 as the proton, then square root of A1 is how much? We know that QE is equal to MA. Acceleration is directly proportional to charge. So charge of the electron divided by the charge of the proton. Okay, QE divided by ME, QP divided by MP. What will the answer be? MP by ME under a root. It is B, no? MP will go to numerator. QE and QP are the same. I think that's the right answer. Yes, it should be MP by ME. I hope you're clear. Right? So these are all the problems based on Coulomb's law. Okay. Next class we will do some problems based on Gauss law. Then we can go to the electrostatic potential. That is the next chapter. Guys, if there are any doubts, ensure you're getting it clarified. Okay. So 1 minute.